Hi, everybody. Okay, now it's time to learn about 3x3 determinants. In the previous video, you saw how to compute a 2x2 determinant. It's a very simple formula. You just learn it and remember it. And basically, we're going to reduce the determinant of a 3x3 matrix to finding determinants of 2x2 matrices. Okay, so it's a very simple formula. That's all we need about determinants for right now. That's all we need about matrices for right now. And so that's all I'm going to introduce. So let's get to it. Okay, so if we are going to talk about determinants for 3x3 matrices, and there are different ways you could do it, but I'm going to show one way that works all the time, and it's convenient when we have to do it sometimes with letters, so you can't just say, I'm just going to have my computer or my calculator compute the determinant of a matrix, because sometimes we're going to have variables involved, and it's not going to make very good sense out of that. So we're going to do expansion by minors. Okay, so I'm going to use very standard notation for a matrix that makes things look convenient, especially when we get to the next little video where we talk about determinants for n by n matrices. 2 and A33. So Aij is just a real number here. Okay, and when you look at the ij entry, that means the entry in row I and column J. So even though it looks like those subscripts are a bit tedious, it keeps a really good way to keep track of things. Okay, so it's very easy to follow along when you use that ij subscript notation. Okay, and so to find the determinant, here's the method. And what you'll see with me as you see the semester go on is I love to abbreviate things. So it's kind of killing me to write out determinant twice. But hopefully my abbreviations will be clear once you get used to hearing me speak more and more. Okay, so to find the determinant, pick your favorite row or column. Okay, so it really doesn't matter which one you pick as long as you remember to alternate signs. And I'll tell you exactly how that works in a minute. Now, why would you pick a row or a column over another row? If you have one that has a bunch of zeros or even just 1 0, that'll simplify the calculations a decent amount. So you would want to pick the row or the column that has a bunch of zeros. And right now we'll say, suppose none of them do, they all look the same. So what you want to do is you want to pick, let me switch colors for you here. So you want to alternate, by alternating signs, you start with a plus in the first row, then they alternate, minus, plus, minus, plus, minus, plus, minus, plus. Okay, and if you had bigger ones, they go like that, you'd continue. So you just keep that in your mind. I wrote it there. We're not changing the values of anything. It's just the thing in pink is to remember. Okay, and now the way you write the determinant of a 3x3 matrix is you pick, let's say we pick, in this example, we'll pick row 1. Okay, but you could pick any row or column. Okay, so now I pick the first entry there, A11. Okay, and now I delete step 3. I'm working on the example as I go. Delete the row in the column. Containing the entry and make a 2x2 matrix of the remaining entries of the remaining entries and calculate its determinant. So in other words, I've picked A11. Now I go up here and I imagine in my mind deleting the row in the column containing A11. So what will that leave me? That will leave me A22, A23, A32, A33. And I take the determinant of that. And remember, for us, straight lines means take the determinant. Okay? So that's the first entry. Now I'm going across the row. The next one goes with a minus. So I take minus A12. In my mind, I delete the row in the column containing A12. Okay. So now what does that leave me? It leaves me a 2x2 matrix with 4 entries. And the 4 entries are A21, A23, A31, A33. Okay. I take the determinant of that. And then finally, the last entry in the row has a plus sign with it. That's A13. Delete the row in the column containing it and take the determinant of the remaining 2x2 matrix. So that's A21, A22, A31, A32. Okay. All right. And now let me get the focus. Trying to get this to focus a little better. There we go. Okay, and now let's work this out. So the determinant of A is going to be A11 times the determinant of that 2x2 matrix, which we know from last time is you take or the last video, is you take the product along the diagonal minus the product along the other diagonal. So it's A22, A33 minus A23, A32. And then I have minus A12. And now take the determinant of this 2x2 matrix, which will be A21, A33 minus A23, A31. And then plus A3, I'm sorry, A13 times the determinant of that last 2x2 matrix, which is A21, A32 minus A22, A22, A31. Okay. So that's the determinant of 3x3. I'll leave it to you to check if you expand along another row or column, as long as you respect, if you expand it on any other row or column in the same manner. Pick an entry, make sure you keep it signed straight. You take that entry, you delete the row and the column containing it and take the remaining 2x2s and then work along your row or column, whichever one you've chosen, and work it out, you'll get the same formula. So it turns out to be independent of the particular row or column you choose. Okay. And that's how you compute the determinant of a 3x3 matrix. So let's do a really simple example. Suppose I take A to be 1, 0, 1, 1, 1, minus 1, 2, 1, 2. Okay. And I ask you to find the determinant of A. All right. I'm going to either use row 1 or column 2 because it has a 0, and that'll simplify things a bit. It'll give me one less determinant to compute. So let's go along the first row. So it goes plus, minus, plus. We're going to use the first row, so that's the only one I really need to remember. So I get plus 1 times the determinant I get when I delete this 1 in the upper right, upper left rather, when I delete the row and the column containing that. So that gives me this matrix. Whoops, 1, 2. Okay. And then I get plus 0 or minus 0 times, and then it doesn't matter because it's 0 times it. That's why I use that row. And then plus 1 times, delete the row in the column containing 1. That's 1, 1, 2, 1. Okay. So now when we compute the determinant of the 2 by 2s, here it's just a 1, so I don't have to worry about that. I get 2 minus a minus 1, so that's 2 minus a minus 1, 0 here. And then I get plus 1 minus 2. Okay, so this is 2 and 1 is 3, minus 1 is 2, so the determinant is 2. Okay, so that's a very easy way to do determinants of 3 by 3 matrices. It's called expansion by minors. Okay, that's it. Be back in a bit with n by n matrices.